So I'm very happy to present you this collaboration we have done with Vitec, which is an institute in the Priorat in Catalonia, and to speak today about enzyme and their use in maceration and the consequence on wine quality. To start, a few words about Oenobrands. Who is Oenobrands? Oenobrands is still a rather young company. We have been founded now 5 years ago as a joint venture between Anchor Biotechnology, the very well-known South African yeast company, and DSM Food Specialties, a very large company in biotech. And in Oenobrands, we operate from Montpellier in south of France, and we combine the activities of both companies for the wine industry. And because we are the joint effort of two companies, we combined the forces from our two parents, which is a very long expertise in wine industry, active for almost 40, 50 years in the wine industry, with a very strong capacity behind us in terms of innovation and development, very modern R&D. I will show you the example in what it means for the enzyme industry. We are backed by production facilities in different continents, mainly in Europe and Africa, and we are active in more than 40 countries. And what is very important for us is to work with you, with the wine industry worldwide. And what is important for us is to identify the needs of the wine industry and to elucidate how can we convert the needs of the wine industry into solutions based on biotechnology. Our expertise is clearly in biotechnology. Now we'll say you a few words about the enzyme industry. DSM Food Specialties is a very important company for enzymes, but I think you all well know what are enzymes in wine, but I'm happy to just to give you a few very general concepts of what means enzymes for the rest of the world. And today enzymes are very widely used in many industries, not only in the food industry as we know, but also in industrial applications. And here we mention the more important, which are the production of biofuel. Enzymes are used very widely in detergents. When you do a laundry products contain many enzymes, textile industry, starch processing, and other activities. And our mother company, DSM, is mainly active in food, but also in biofuel and in the feed industry for animal feed. And when we speak of industrial applications, I also forgot to mention pharma application. Enzymes are used in detergents, in biofuel of first and second generation, so to produce essentially ethanol from starch that was the first generation, but also from from raw material from starch production, that's the second generation, bioplastics, textile, conversion of starch, and digestive aids. Now if we come to food enzymes, I don't know if you're aware that enzymes are present in almost every food we have every day. The first application market by size is baking. Every bread you eat does contain enzymes. Dairy product, cheese, and also milk when it's a low lactase product. Meat, oil degumming, brewing, for beer production, enzymes are very much used, fruit processing, and wine, but also alcohol, production of mayonnaise, biscuits, snacks, patatine, for instance, etc. And our company, DSM Food Specialties, is active in all these markets. And for wine, they ask us, and that's why they founded Oenobrands, as a company to take care very specifically of the application of enzymes and other products for the wine industry. And our brand in enzymes does exist since 1922. It is Rapidase, and Rapidase is active in the wine industry since 1970. So we have more than 45 years now of experience as producer and as developer for wine enzymes. So more than 1 century of history. Our company was founded by Auguste Boisdin, who was a student of Louis Pasteur in 1906 in the north of France. The factory is in the city of Seclin, and we are still operating there, so with more than now 1 century of experience. And we have a very large-scale production capacity. We are using mainly one type of fermentation technology, which is submerged technologies. There are different ways to produce enzymes. And we have up to 100 cubic meters fermenter there. It's an old factory, but the equipments have been continuously improved. And I can tell you, I've visited last year, that it's a very modern factory. And in terms of development of new enzymes, we don't operate only us in Oenobrands, but we are backed by a very strong company, which is DSM, and they have a very strong biotechnology center, which is in our headquarters in Delft, in Holland, where we apply all, let's say, techniques and scientific expertise to develop new enzymes. I mentioned already, we base our development on understanding the needs. So that's what we call here in this slide, market and customer. Then we try to translate a need. Let's take an example. Maceration, we will come back to this, of grapes. How can we improve maceration of grapes? So we look at the biochemistry of grapes. We try to understand how can we convert the biochemistry and how can we play on the biochemistry of grapes with enzymes. When we have identified let's say, the biochemical target, we have tools which are genetics and screening to improve our production organisms. We have a control of fermentation, we have a control on recovery and formulation of enzymes, and this converts into a product that is then proposed to the industry to solve the problem we have identified as market needs. So just a few slides. We have a center, like I said, or DSM Biotechnology Center, where we have capacity to do screening of thousands of strains every day. We have a lot of robotics, miniaturization. We can start from 10 microliter fermentation. We can screen for new enzymes that we think are important to solve a need of the industry. We have also very deep knowledge in the genome of our production organisms. That's already a bit an old publication. It was already in 1999 when DSM, with a large group of scientists, has been involved in the complete sequencing of Aspergillus niger genome. And this knowledge does help us to every day identify new enzymes and develop them for different industries, as I mentioned. But we don't only work with Aspergillus niger. We produce enzymes from at least 25 different microorganisms belonging to different species. I already mentioned we can ferment from 10 microliters, so very, very small volume. And we have capacity, of course, once we have identified the right microorganism to produce an enzyme, we can scale up to 100 milliliters, 10 liters, 1,000 liters at the pilot scale. And then we can move to our production facility in Seclin, north of France, where fermenters up to 100 cubic meters. So we have really capacity to produce as much enzyme as wanted. I don't think I will enter into much detail of how you produce an enzyme, but maybe very briefly, every time we produce a product, we start always from the mother culture, from the original production strain, so to avoid any deviation of the product. And what is interesting is that in only 3 steps, we will move from a gelose, so a few milliliters in a gelose, to a main fermentation, which is, as already mentioned, up to 100 cubic meters. So we can produce a very large quantity of enzymes in a few days, starting from a gelose, from a very simple mother culture. And then we get a fermentation broth, so which is a complete mixture of microorganisms with the enzyme in solution. We separate the microorganism by filtration or centrifugation, and we get a filtration storage which just contains the enzyme, which is always concentrated by ultrafiltration, and in some very specific cases it can be purified by chromatography, but we don't apply this to our wine enzymes. And once we get these concentrated enzyme solutions, we can design different recipes by mixing products, and this is we mix products to achieve the effect we target, in our case, in the case of winemaking, looking at different applications we have a number of fermentation products, quite a large number, and we mix this product in different proportions to get the desired result in winemaking. I think you know, two types of formulation exist for wine enzymes. They can be liquid or they can be granulate. When they are microgranulate, they are spray-dried. It's a technology which allows to preserve the enzyme activity, and they are spray-dried on a support which is maltodextrin. And when they are liquid, I will come back to the recipe, but we stabilize with a very efficient stability system so that the product remains stable for 2 to 3 years or even more without any microbiological spoilage or loss of enzyme activity. Then once we have the product, we have, I think, a world-class analytical facilities. Of course, we do enzyme analysis, but we have also very large equipment in chromatography, HPLC, and we have also very large NMR facilities up to 600 megahertz, which is quite a big equipment, and we do also any type of mass spectrometry. So we can really have all the tools to control and to monitor the quality of our product. A few words about enzyme and food labeling, about the rules which are applied. Enzymes are considered by the authorities, especially in Europe, but also in the rest of the world, as processing aid, which means they are considered as either absent from the final product, which can be bread, I say yogurt, cheese, etc., or when they are still present, they are considered as not functionally active. And it's important for us because it means there is no labeling requirement for enzymes on the final product. It applies, of course, to wine, but it applies to any type of food, with two exceptions I will show to you. So if you look at the label of a cheese, a label of a fruit juice, etc., even if it has always been produced with enzymes, they are not mentioned on the label because enzyme is a processing aid, as it has nothing to do with the gene status of the enzyme. Two exceptions, invertase. You may look, if you like, Quality Street. You can look that you will see invertase is mentioned on the label. It's used to avoid to have sugar crystals in the product. Or lysozyme. You can see sometimes in cheese, when lysozyme has been used, it's present in the label. They are considered as not processing aid, but additives. And as we know, in wine, we have now a requirement to label lysozyme, but not only for the additive status, but mainly for the allergen status linked with lysozyme. A few words on the specific European food law and enzyme regulation. The European Union has been working very actively together with the enzyme industry on a new regulation, which was published in 2008 as Regulation 1332. And it does describe a number of things that are already implemented in the wine industry, of course. They define rules for labeling. In the case of rapidase, we follow the rule of enzymes which are used by the industry and not sold to final consumer. There is no label requirement on final product, this I mentioned. But what is more interesting, and I think it's important for you to know, the European Union wants to publish a positive list of approved enzymes to be used everywhere in the food industry, so this will also include wine. And this is something where the Enzyme Association, which is called AMFEP, has been very active over years. And we have submitted in March 2015, we have submitted files for each enzyme class which is used by the food industry. And don't worry, all wine enzymes, and especially pectinases, but also the secondary activities we use, have been included in these files. A tox dossier will be submitted for each enzyme. It has quite a cost. And in 2020, the European Union will publish a positive list of all enzymes approved for the food and for the wine industry. Until then, till 2020, we follow the existing regulation, and in our case, we follow a French regulation, which is extremely strict. It's by far the most strict regulation in terms of enzyme, and this is the one we are following for our production in Seclin and for the enzyme we commercialize. So I hope I was not too long, but I hope to have shown you a few things about what is behind an enzyme. When you buy a product, it seems to be simple, but there is a very complex industry, and many things are behind, let's say, behind the label. Now, if we speak of enzymes in winemaking, this I think you know. These enzymes are mainly degrading polysaccharides. Of course, you all know the word pectinases, but we have also enzyme active on cellulases, beta-glucans, so I just presented before, xylans, and a number of other polysaccharides. We have also, of course, enzyme active on the aroma precursor, which are the glycosidases, and we have specific enzymes like lysozyme and urease, which is an approved product, but we don't think it does exist commercially. These enzymes are produced mainly from Aspergillus niger, but also Aspergillus aculeatus, and a few trichoderma, like Trichoderma arsianum for the beta-glucanase, or Trichoderma longibrachiatum. And of course, lysozyme is extracted from egg white. There are different production techniques. I mentioned the one that we apply for our rapidase production. Other companies are using another technique which is called surface fermentation. I will not enter into details. And I already mentioned the two generally approved and used formulation, liquid, which is based on the stabilization system with glycerol and KCl, which is absolutely approved by the authorities, and microgranulation on maltodextrins. Just one word on pectinases. Maybe you have already seen this picture. This picture is not to enter into details. It's just to keep in mind, we say one word, pectinase, but pectinase does cover an extraordinary diversity of enzyme activity. Why? Because pectins are an extraordinarily complex group of polysaccharides. The word is simple, but this simple word is covering a very large complexity of structure, different, let's say, parts, homogalacturonans, riboglucuronans, etc. I will not enter into details, but for each structural part, you have a number of enzymes which allows their degradation. And that's why I explained we should never use the word pectinase. We should always use the word pectinases, because we really speak of a large diversity of products. But it's also nice for us, enzyme producer, because we can play around the type of activities we have to have different ways to degrade the pectin, looking at the objective we have in winemaking. In terms of application of enzymes in winemaking, I think this you know much better than me. There are three main types of objectives. Winemakers who want to improve their process, saving time, better yield, better flotation conditions, faster maceration, etc. Winemakers who want to target quality improvement, and in a few cases, winemakers who want to solve a problem, like for instance, if they have a big filtration issue due to beta-glucans. And today we will focus on quality enhancement, and we will focus on quality enhancement in red wine making. What is the main target when you use an enzyme for maceration in red wine making? The main target is enhance the quality due to an increase of extraction of polyphenols, especially of tannins, also of anthocyanins, but the real target is to have more structured wines due to higher polyphenol extraction. And to achieve this, you need a vast range of enzyme activities, because I will come back to this. You want to degrade as much as possible the grape skins to extract all these compounds which are present in the skin. It's applied mainly to maceration processes. I will not speak of thermovinification or specific process today. And the benefit for winemakers is to have more color, more stable color, more structure in their red wines. If we look at this, I think I'm not learning you anything. These are enzymes which are used during the maceration phase. And what is important during the maceration phase, that the target of all red wine making techniques is to extract as much as possible compounds from the skins. As you know, the flesh, grape flesh is the soft. It's easy to extract compounds from the flesh. It's complicated to extract compounds from the skin. And you need enzymes which have secondary activities. So there are pectinases, because you have to degrade the pectins there, but you also need a number of secondary activities to really weaken the cell walls. These cell walls, which are from the grape skin, are rather thick, They have a high content in hemicellulase, cellulase, and you really need to weaken these cell walls if you want to extract more polyphenols from the skin. After the use of enzyme, of course, you know, you go to press, you drain, you press your wine, and you go to maceration. So that's really the target of red wine maceration enzyme. In our company, we propose two different recipes, one which is, let's say, an historical product, which is called Rapidase Extra Color, and a product that we launched a bit more recently, which is called Rapidase Extra Fruit. The target is slightly different. This enzyme is targeting more release of aroma precursors and a little bit less of polyphenols. As you can imagine, it's not easy to make a completely black and white extraction because we still macerate grape skins. But we have a completely different recipe to achieve these two different targets. And now I would like to introduce the works that will be presented by our scientific partner, Anna Brühl from Vitek, that, as you know, enzymes are used and maceration is applied in red wine making to extract grape skin compounds. And most of them are positive for quality. We mentioned, of course, anthocyanins, aroma precursors, polyphenols. But it's also well known that when you do maceration, you have a tendency to extract potassium from the skins that go into the wine or into the must, fermenting must that becomes wine. And it's also well known that when you extract more potassium, you may affect negatively pH, so you can have a higher pH, or you may affect acidity level. And that's why we initiated this study. We wanted to understand whether the use of maceration enzyme would negatively impact wine pH and wine acidity. So I'm happy to introduce Anna Brühl for the second part of the talk.
Thank you, Patrice.